Hey guys, I want to start this lecture series by talking about the applications of classical conditioning. Now, you'll remember in previous lectures, we've talked about the mechanics of classical conditioning, which essentially boils down to pairing a neutral stimulus with an already existing reflex. Pavlov did it with the dogs when he paired the sound of the metronome with the reflex. Remember, a reflex is a relationship between a stimulus and response. So he paired the sound of the metronome with the food powder, and the food powder eventually paired with the metronome, created drool, essentially salivation, to the sound of the metronome. What was previously a neutral stimulus took on an eliciting property. We looked at a couple of models for how that happens, mostly along the lines of Pavlov's stimulus substitution theory and the Rescorla-Wagner formula that you had to learn for exam 1. What I want to do today is bring that further into the real world and show how it works. And we've already visited this topic before, and that is starting off with John Watson. Now, Pavlov did his work around the 1890s, and he was Russian and a physiologist, not a psychologist. As a matter of fact, psychology of the day wasn't even really scientific. It was all Freudian and psychoanalytic with a little bit of mysticism thrown in. It got to John Watson not more than 20 years later, which was the blink of an eye in terms of how fast that information was transmitted. Remember, Watson was an American psychologist in New Jersey, and he had to find Pavlov's work, which was written in Russian, that had to be translated into English and then transported over the ocean via ocean liner to wind up in a library for this American psychologist to read up on it and to understand the implications. And we've already talked about the actual experiments that he did. The first was pairing essentially a feared stimulus with a white rat. And you'll remember the little Albert experiments that we talked about. Now, in the previous lectures, we talked about how important Watson was and why this was so important, because he did something that echoes through to this day. Before Watson, there were other experiments in classical conditioning, but they all had to do with things like salivation or pupillary dilation or blood pressure. And what Watson did when he paired that traumatic sound with the rat was to demonstrate that you could classically condition nothing less than human emotion. Now, at the time, this was even considered to be sacrilegious. Let me explain. At the time, there were different ways of looking at human emotion. One was Freudian, and we've talked about that in some detail. Another was the philosophical approach that was a carryover from a philosopher named René Descartes, who was famous French philosopher in the 16th century, who believed in the theory of dualism, that your mind and your body are separate things. Now, if your mind is separate from your body, then that means that there is the presence of a soul, a watcher who's looking out through your eyes, that is separate from any kind of biological process. And if that's the case, then you as a thinking being have a soul, something that transcends your physical presence. And in order to have that higher level of cognition, then you would have that emotion, and the emotion would come from your mind. In other words, all of your emotions would be coming from your soul, that God-given transcendent part of you that was immortal. And if we're going to take a scientific lens to the soul, then a lot of people at the time believed that that was outright sacrilege. And Watson caught a lot of heat from that community for committing what was essentially a sacrilegious act. However, what he did was form nothing less than the foundation of all modern psychology. I talked before about the fact that A lot of people, and myself included, consider Watson sort of the Voldemort of psychology. He did terrible things. He made his entire career off of torturing babies, but he also did great things. And so what we're going to do is we're going to take a little bit closer look at that. The first thing that we want to look at is the classical conditioning of fear. And in order to do that, we are going to look at a conditioned emotional response. Now, a conditioned emotional response is a classically conditioned emotion. And we've talked in class before about the fact that nearly all of our emotions are classically conditioned in one way or another. So in this case, we're going to talk specifically about a phobia. And this is a classically conditioned emotion that has grown into essentially an unreasonable or problematic level of functioning. Now, when we are talking about phobias, we are talking about something that the person knows is irrational, but it prevents them from fully functioning in their life in one way or another. There are some phobias that are more common than others, and there's a biological predisposition for certain kinds of phobias. For example, they fall into three major categories. When you study abnormal psychology, you'll study the categories of phobias. The first is situational phobias, such as thunderstorms or the dark or enclosed spaces or heights or flying. Critter phobias, which are spiders and snakes and creepy crawly things, and blood injection and injury phobias. And out of those three, all of them are born of classical conditioning, just in the same way that little Albert was afraid of the rat. That would be a critter phobia, a rat phobia. All of them are gotten by classical conditioning, but blood injection and injury phobia seems to have the heaviest biological component. As a matter of fact, there is one diagnostic characteristic for BII phobias that don't exist in the other ones, and it's a condition called vasovagal syncope. It's a fancy name, but let me break it down. Vaso just means your blood pressure. Vagal refers to your vagus nerve. It's one of your 12 cranial nerves that actually regulates blood pressure. And syncope is just a fancy science word for fainting. And what happens with blood injection and injury phobias is that when you see this classically conditioned feared stimulus, like a needle or blood or surgery or some kind of gross thing, what happens is your vagus nerve responds to the rise in blood pressure. You see the feared stimulus, your blood pressure rises, your vagus nerve interprets that as an emergency, and it makes all of your veins and capillaries vasodilate, to open up so that you can not blow a gasket, essentially. The side effect of that is that all the blood drains from your head and people start to faint. And that's why you see so much more fainting in things like needles and injections and blood than you do in any other kind of phobia. So what I want to do now is go back to the original Little Albert experiments and actually take a look at some of the stock footage, some of the footage that Watson was able to make. Now, let me share the screen here. Or try to share the screen here. There you go. And what I want you to do is watch the video that I'm going to show you. Now, keep in mind that this is Watson and Rayner doing the original Little Albert experiments in 1910. When you watch it, the sound is off. There's a thing called Foley artistry where people go in and make sounds, you know, for movies afterwards. The problem is with Foley artistry, a lot of times in science videos, they don't understand the science behind it. So when you hear the loud noise, it's not going to be the actual loud noise that happened. And more importantly for us, the timing is off. Remember, timing is everything in classical conditioning. And when you watch little Albert's reactions, remember that adults have a very different startle reaction than infants. Adults have these kind of large flexion reactions. You know, you jump when you're startled. Infants don't do that. They're much more primitive. They have what's called a freeze reaction. So when you're watching this video, what I want you to do is ignore the sound, but I want you to watch little Albert's reaction when he freezes and then falls over. And that's when you'll know when the unconditioned stimulus has been applied. So let's take a quick look. So some more backstory on this, because Watson is an interesting historical character. Remember, the experiment we refer to as the Watson and Rayner experiment. And Rayner was his graduate assistant. We talked about this in class a little bit. Watson eventually left his wife and married Rayner. And when that happened, he got fired from the university that he was working at, and that didn't slow him down at all. As a matter of fact, he went on to make millions of dollars using classical conditioning in advertising, which is actually a topic that we're going to be looking at in some detail later on in a separate lecture. Now, little Albert's actual story is sad. Little Albert's mother was a nurse in the daycare where Dr. Watson had recruited a lot of the babies that he worked with. And she had no idea that any of this stuff was happening to little Albert. When she did discover that her son was being mistreated so badly, she withdrew him from the experiment and left, and Watson and Rayner were unable to reverse the effects, which they had planned to do, but she was so angry, obviously, she didn't want her baby to be tortured anymore. Nobody for a long time knew what had happened to little Albert. As a matter of fact, he would be he would probably be about 103 right now had he lived, but he didn't live for long. He died at about 6 years old from one of the old-timey consumption diseases, probably something along the lines of tuberculosis. A lot of work was done in the 1990s to actually track down who he was, to see if they could thank him for his contributions to psychology and to mental health writ large. And it turns out that he lived a very short life, and it's unknown whether or not he carried that phobia with him for the rest of his life or not. Now, I'm going to end here, and in the next set of lectures, we're going to be taking a look at phobias and classical conditioning, and how, if we get emotions from classical conditioning, and in particular phobias, which we're dealing with at the moment, how do we reverse that? And then we're going to use that as a model for most other emotions, both in their creation and in their modification. And I'm going to show you on a step-by-step basis how classical conditioning is the foundation for nearly all modern psychotherapy, using the Rescorla-Wagner model that we looked at earlier.